Hello everyone. Welcome to another class in the subject EST 120 Basics of Civil Engineering. So we were discussing the topics in module 1. Already we discussed what is civil engineering and what is the relevance of civil engineering in the overall development of a country. In today's class, we'll be discussing what are the various disciplines of civil engineering. So we know that civil engineering is a professional discipline of engineering which mainly deals with the designing, the constructing and maintaining the natural and physically built environment. Also, we already discussed the role of civil engineers. So we know that civil engineers are responsible for the building of various structures like the roads, the bridges, the skyscrapers, canals, dams, and various other big structures. And also, they are responsible for creating the surroundings as we know it and to improve and protect our lives. And they are also responsible for generating sustainable energy in this era of fast depleting fuel and resources. Moreover, the civil engineers also ensure that there is supply of clean water to a community. So we know that we cannot imagine a world without water, isn't it? So it is the civil engineers who are responsible for ensuring the supply of water for the waste management, and there are so many other roles played by a civil engineer. So, like I said, civil engineering is a branch which deals with the design and construction of the various structures like roads, bridges, and many other large scale structures. We can say that it is an established profession that has existed since the establishment of the first permanent human settlements. So, within the civil engineering profession itself, there are many subdisciplines which one can specialize in, and as a wide branch of engineering, civil engineering has various disciplines which we will be discussing in today's class. So, like it is shown here, civil engineering is a combination of various disciplines like structural engineering, construction engineering, geotechnical engineering, there is environmental engineering, transportation engineering, etc. So, we will be discussing each of these today. So, here in this figure you can see there is a depiction of the various disciplines of civil engineering as shown. The civil engineering is a composite of environmental engineering, transportation engineering, water resources engineering, surveying and remote sensing, construction engineering, structural engineering, and geotechnical engineering. So, briefly, I'll be explaining to you what are each of these disciplines. So, firstly, coming to construction engineering. So, the word construction itself gives you the literal meaning is that it involves the planning and management of the entire construction process of any project. So, it includes also the logistics of scheduling the workers using software such as Microsoft Project, the equipments and materials throughout the life cycle of a project. So, which this can be anything from a highway or it can be a high-rise building, etc. So, knowledge of the construction process is very much required to work in this field along with the business management as well as the economic sides of a construction project. So, it mainly deals with the planning, the scheduling and execution of the various constructional activities. And like it is listed here, it comprises of men, material, time and money management, and emphasis will be on new construction practice like using software, etc., and an use of appropriate and local technology, safety of men and material, utilization of the marginal materials, etc. And also it includes the supervision of any project. So this is what is constructional engineering. So the construction phase of a project represents the first tangible result of any design. So I hope it is clear. So this is what construction engineering is all about. Now coming to one of the most important disciplines in civil engineering, that is structural engineering. So structural engineering actually involves the design of the small and the large structures so as to ensure that they can withstand the stresses and pressures of the environment and remain safe for use throughout the lifespan of the structure. So we know that whenever a structure is constructed, that there will be various types of loads and stressors that will be acting on the structure. So structural engineer actually designs all these, and he ensures that the structure will remain safe for throughout its lifespan. And it is also an understanding of the building physics and the statics, which is required along with the local building design codes to work in this discipline. So there are various codes or rules that are specified when you there are specific codes which a design engineer or a structural engineer refers when he designs a structure. So structural engineer, it's all about designing a structure, and structural engineers also face the challenge of designing structures that support their own weight and also the loads they carry. And this results in an extreme force from, like I told you, the structure is acted upon by various forces, isn't it? There may be the force of the wind, the earthquakes, the temperature changes, temperature variations, etc. So all this has to be borne by the structure, and it is a structural engineer who designs the structure taking into consideration all these factors. So the structural engineers also develop appropriate combinations of various materials that is used in construction. So we know that when we construct a building, we use various materials like concrete, timber, steel, plastic, etc. And then nowadays there are new exotic materials that is being used in the construction. So it is a structural engineer who will develop an appropriate combination of all these materials, and they also plan and design and also visit the project sites in order to ensure that the work is done properly. So when we say a structure, it is actually an assemblage of two or more basic elements like a beam, a slab, a column, etc. So the various parts of a structure, components of a structure, etc., we will be discussing in the further topics. So this is what structural engineering is about. It actually involves the design of small as well as large structures. Now coming to the next discipline, that is geotechnical engineering. So geotechnical engineering mainly deals with the design of a structure's foundations. So we know that every structure has a foundation, isn't it? So foundation is actually the base of a structure which gives stability to the structure. So whenever we have to study the foundations, we also have to have a knowledge about the geology that is required in order to understand the properties of the soil or the rock or the clay over which the foundation is constructed. So geotechnical engineering mainly deals with the study of the soil as well as the foundations, and some typical tasks that are associated with the geotechnical engineering includes the slope stability assessment, then the evaluation of the landslides. So natural calamity landslides, isn't it? So they have to evaluate the occurrence of landslides, the fall of the rocks, as well as performing various calculations in order to assess the load bearing capacity of the soil and the rock. So when we plan construction of a structure in a particular soil, we have to have an idea about the nature of the soil, how much load the soil can bear. It can be soil or a rock, whatever it is. So this study is what we do in geotechnical engineering. So I hope it is clear. So here just some pictures showing some soil test being conducted by the geotechnical engineers. Now coming to the next discipline, that is environmental engineering. So environmental engineering, we all know that it deals with the protection and protecting the public from the destructive environmental effects. So some of these processes like water and air pollution control includes the control of the water and air pollution, the recycling process, the waste disposal, so municipal solid waste disposal, waste from the industries, the industrial waste has to be disposed properly. So all this will come under the environmental engineering, as well as the soil contamination and large scale farming, etc. So the responsibilities of the discipline include minimizing or preventing the harmful contaminants that are released into the surrounding environment. So whenever a pollutant or any harmful material is released due to various actions like from an industry or from a household activity, whatever it is, there will be release of waste or pollutants. So the responsibility of an environmental engineer is to minimize or to prevent the harmful effects of these in the surrounding environment. So this means the knowledge of basic chemistry and biology are also required along with the processes that can reduce and eliminate their release. So an environmental engineer will have to have a basic idea or basic knowledge in the field of biology as well as chemistry. So the main role of an environmental engineer is to work towards achieving a healthy environment, and this is about environmental engineering. And there are also various other sub divisions of the fundamentals of environmental engineering. It includes the water quality assessment, the groundwater pollution control, the environmental chemistry, hydrology, disposal of the solid waste, then environmental regulations, environmental impact assessments, so on. Now coming to transportation engineering. So transportation engineering, you all know it is, the word itself has a meaning in it. So it deals with the design of the transportation systems. So what are the various transportation systems? It includes the highways, the roads, the other public transportation networks, etc., the airports, isn't it? So in addition, the operation and the maintenance of these transportation systems are also a part of the responsibilities of a transportation engineer, along with an understanding of the traffic control systems. So transportation engineering also has many subdivisions like the traffic engineering, the highway pavement design, the railway engineering, airport and harbour engineering, road alignment, tunnel engineering, etc. So the quality of a community is directly related to the quality of its transportation. So we know that if there is a good transportation system, that means we can say it is a very advanced community. So transportation engineers work to move people, goods and materials safely and effectively, and they find ways to meet our ever increasing travel needs on land, air and sea, etc. So it is the transportation engineers who design, construct and maintain all types of the transportation facilities. So this is the main role of a transportation engineer. So here you can see a very advanced road network system. So all these are the design and implementation by the transportation engineers. One more figure. Now coming to the water resources engineering. We all know that water is very essential to our lives, and water resources engineers mainly deals with the physical control of water. So they work with others to prevent the floods, the supply of water for cities, industry and agriculture, and also to protect the beaches or to manage and redirect the rivers. So it mainly deals, we can say that water resource engineering mainly deals with the management of the water supplies essential to man for everyday life, for day-to-day life water needs. And this means there is an understanding of the basic water processes that is required so as to provide a clean supply of water and can be used for drinking and living. And some tasks that are related to the water resources engineering includes the design of the culverts, the dams, as well as the erosion protection works along the river banks. So it is also, we can say it is related to the hydraulics or the irrigation engineering. So dams etc. comes under irrigation engineering. So we can club all these together. Hence we say it as hydraulics, water resource and irrigation engineering. Now coming to the next one, that is geotechnical, coming to GIS, that is geo information system and remote sensing. So this is also a very important branch in civil engineering. So it is also combined along with surveying. So we usually say it as surveying and remote sensing. That is how we say it. So surveying is mainly done to determine the positions of various points on, above or below the surface of the earth. So whenever we plan a structure or any project, we conduct surveying initially. So surveying is mainly conducted to take various measurements or to study about the topography, etc. So any process which involves the determination of the positions of various points, that is the location, how much distance it is away from a particular point, or how much is the height, or whatever. So any measurements, any process which involves taking measurements, we classify it in the group of surveying, and these are mainly required for any project in civil engineering. So surveying has advanced from chain surveying. So earlier we used to have chain surveying. So it is a process where measurements were taken by using tapes or chains. So now it has advanced to a far more uh, advanced state where we call the remote sensing process. So this surveying has advanced to remote sensing with the advent of various electronic and sophisticated instruments like the total station, etc. So this can be said as a branch of engineering, or it is the science of obtaining the information about the objects or areas from a distance, like from an aircraft or from any satellites. So a geographical information system, or GIS, is a system that is designed to capture, to store, to manipulate, to analyze, to manage and present all types of spatial or geographical data. So remote sensing and GIS is actually an advanced form of surveying. So, like I said, surveying is mainly used to determine the positions of points, various points, that is by taking various measurements, like linear measurements. It can be direct measurements or indirect measurements. It can be linear measurements or angular measurements. So by taking these measurements, we will be determining the positions of various points. So this process is called as surveying, and the activity involved in the collection of the topographic features of a location. Whenever we go for a construction, we have to study the topography or the nature of the land. So this process also comes under surveying. So that is what, like I told you, from surveying, now it has advanced to a more sophisticated system which we call as remote sensing and GIS, that is the geographical information system. So students, these are the various disciplines of civil engineering. So I hope you got a clear idea or clear picture on what is civil engineering and what are the various disciplines of civil engineering. So this I'll just show you once more. So these are the various disciplines of civil engineering. So you all can just go through this, and thanks for listening. Thank you.